Hello, good day, learners at home. Welcome to this wonderful period. Again, we're going to study mathematics and for a topic called Pythagoras Theorem. And it's studied by all students in JSS 1 to 3, sometimes even in primary school. So your attention is highly needed. I remain teacher Ogaranya Matthias Nadezia. Now, Pythagoras Theorem originated from a man called Pythagoras. He developed the theorem. His name is Pythagoras. What is your name? You can develop a theorem and it will be mentioned after your name. I am teacher Matthias. I can develop a theorem. You call it Matthias theorem. Your daddy has a rule at home. That is according to my daddy's rule. You're not doing it because you want to do it, but that's what your daddy wants. A man called Pythagoras used a right-angled triangle. Label them the longest side of a right-angled triangle. He called it hypotenuse. Hypotenuse is a constant side of a right-angled triangle. It is the longest side of a right-angled triangle. And it is the only angle side that is facing angle 90 degrees. This 90 degrees makes this triangle a right-angled triangle. So you need to note the longest side of a right-angled triangle. It is a constant side because it is facing constantly the 90 degrees. And this 90 degrees is what makes this triangle a right-angled triangle. Remember, we have many triangles. We have the isosceles, we have the equilateral, we have the scalene. But this theorem was developed using right-angled triangle. These other sides are called two small sides. Maybe in another topic, I will give it names. But for now, we'll describe just one hypotenuse, the longest side. We need to know, and for the sake of this lesson, and the two small sides of a right-angled triangle. The A, small letter A, and small letter C are known and identified with the two small sides of a right-angled triangle, while letter B is used to identify the longest side of a right-angled triangle called hypotenuse. So we're going to be representing hypotenuse with B, the two small sides, one with A and the second one with C. Now, look at his theorem. The man sat down after years of research and constructed a right-angled triangle. He gave hypotenuse 5 centimeters, the two small sides 1, 4, another one 3, and subdivided the 3 centimeters into 1, 2, 3, 4, 5, 6, 7, 8, 9. That is each unit of centimeter, 1 square centimeter, 1 square centimeter, 1 square into 9 of them subdivided. Also, he has here the other second small side subdivided into 4 centimeter, and when you count them, it will give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 9, I have 16. And the longest side, he measured it 5 centimeters and subdivided into different square meters. And he got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. What did he resolve? And his conclusion? His conclusion is that the two small sides of a right-angled triangle, when squared, 3 squared gave us 9, 4 squared gave us 16, that if we add the two small square sides of a right angle triangle, it must give you the hypotenuse. So 16 plus 9 will give us 25. And this is how the Pythagoras rule was brought out. What did he say in conclusion? I'm taking you over to this page. He said that B squared, remember I told you B represents the longest side, the hypotenuse, is equal to the addition of the two square sides of the small side of a right angle triangle. That's A squared plus C squared. And he went further to do what we call in just 3, change of subject. That is, if you are looking peradventure for either of the 2 small sides, for A or C, by making A the subject, we have B squared minus C squared. By making C the subject, we have B squared minus A squared. So with 1, 2, 3 formulae given on the board, it means you can find either of the 3 sides of a right angle triangle using this rule called Pythagoras rule. I'm sure you are following. Then we have applications. Let's practicalize the usage of the 3 if time permits us. Now, the first one is the right angle triangle. Remember, I told you it must have this mark for you to know it is a right angle triangle. Out of the 3 sides of this right angle triangle, 2 sides were given and 1 side is not given. First assignment, and what you need to do is, out of the 3 that is not given, is it the big side or one of the small sides? If it is the big side, the formula is B squared equals A squared plus C squared. If it is either of the 2 small sides they ask you to find its value, then you use any of these 2 will give you the same answer. From that, we go further. Say using A squared equals B squared minus A C squared, where A is given as X, B is given as 13, and C is given as 5. Now, the unknown is X, represented with letter A. But in this question, we are asked to find X. Now, using the rule that says A squared, we now use X squared because what we are looking for is X. X squared equals B squared, which is 13, 13 squared, minus C squared, C, which is 5, 5 squared. And C squared means 13 times 13. And from our multiplication table, we have 169. And 5 squared means 5 times 5, which is 25. The difference between 169 and 25 is 144. Pause for a while, let me inform you. In Pythagoras theorem, most of the values are always in a perfect number. At this elementary stage, you may likely not be given numbers that are not perfect number. Even though in the senior classes and the universities, you can be given any number. But for a start, be conscious of getting a difference or a sum that will lead you to a perfect number. And 144 is a perfect number because the square root of 144 will give us 12. How do I mean? 12 times 12 gives us 144. So the square root of 144 will give us 12 meter, which is the value of the x. There's something I want you to note. Here is x squared, and here is x. The difference between this and this is that this is having square root, square, and this is not having square. These two that's supposed to be here as power disappeared because of the appearance of the square root. So we found the square root of both sides, and square root of x squared will give us x, and the square root of 144 will give us 12. So the value of the unknown side is 12 meter. Then the 12 meter will form what we call Pythagoras triple. Triple is still after the name Pythagoras, the man who developed the theorem. Then the triple is that the 12 value of x, 5, and 13 forms what we call Pythagoras triple. How do you confirm that this answer is correct? It is by looking at what we call Pythagoras triple. What do you do to find out that this answer is correct, even before your teacher goes through your assignment? What you do is 12 squared plus 25 squared must give you 13 squared. I want you to try that and tell me if it is true. 5 squared plus 12 squared must, underline the word must, give you 13 squared. And 10t squared is 169. If you add 144 plus 25, it must give you 169. In that case, even before your teacher goes through your work, you have given yourself assurance that I've gotten this answer because the three sides has formed what we call Pythagoras triple. Now, let's go to number 2 example, where we are asked to find the value of the longest side. This time around, we were told from onset that the rule says that the value of the longest side is equal to the summation of the square of the two small sides. The two small sides here are given as 3 centimeter and 4 centimeter. Now we are looking for y. Y has taken the position of B. A is 4 and C is 3, all squared. And the square root of 4 is 4 times 4, which gave us 16. And square root of 3 is 3 times 3, which is what? 9. Take note, many children have made mistake to say 4 plus 4 to give you 8. In powers, we multiply. So, it is 4 times 4, 16, and 3 times 3, 9. And the summation of 16 and 9 gives us 25. Just as I told you, the square here disappeared because of the square root of 25. And square root of 25 is 5. So the value of the value of the y is 5 centimeter. Therefore, 3, 4, 5 can be named or called Pythagoras triple, which if you follow the same pattern, you will confirm if your answer is correct or not, even before you get to the teacher. I don't know whether you're understanding what I'm saying. It is something that is fine, interesting. You find it in your textbooks, you find it in many books from the basic primary, the upper primary to junior secondary. You can always look at Pythagoras triple and Pythagoras rule. You need to get familiarized with it by practicing. I don't like you to memorize the formula because it can fail you. The best way to master the 3 rules you are going to use in solving any problem in right angle triangle is through constant practice. I'm going to give you an assignment, 1 or 2, then you will increase by constant practice. Get me posted, and we will always solve together when you have an issue. Now, over to assignments. I have 2 questions for you on the board for your assignment. Find the values of the unknown using the Pythagoras rule. It's left for you to identify the sides we are looking for, whether it is the longest side or the shortest side. Another area we're going to look quickly before I leave you is how do I identify a Pythagoras triple? You'll be given three, 4 dash. What will be here? And the best way to get here is to write 3 squared plus 4 squared is equal to this column. 3 squared is 9. 4 squared is 16. and the addition of the 2 gives you 25. So the square root of 25 is equal to 5. Therefore, the triple are 3, 4, and the 5. So this is the best way. You can even score yourself, check your work, and confirm that what you have done is the best. You call this check. You can use the Pythagoras theorem, triple, to check your work at home. Then in confidence, give it to your teacher the next day, and I'm sure you have the best mark. Thank you. I hope to meet you again, ready for mathematics. Same station, same time. Stay safe.
Thank you.